Our project is optic speedometer. Here for voltage source we used 4 battery each of 1.5 volt. We connected one resistor, then 2, then 3 in the breadboard. Each resistance is 1.5 ohm. We connected the DC motor of 5 volt with the circuit and attached a CD on it. We made a narrow slit on the CD so that it can light pass through. We attached a photo sensor on the bottom of the CD and connected with the earphone wire so that it can convert the light wave to a sound wave. Now we will introduce one resistor and then switch on the system and take the voltage reading from the multimeter and impulse reading from the laptop. Now on the laptop we will calculate the impulse of the sound wave.
After performing the experiment, we got 3 readings for different resistance. In the first experiment, we took the value of resistance 1.5 ohm, that is we used one resistor of 1.5 ohm. So the resistance 1 is 1.5 ohm. And for the reading 2, we we took 2 resistors of each 1.5 ohm. So here the total resistance is 1.5 into 2, that is 3 ohm. And for reading 3, we used 3 resistor of each 1.5 ohm, that is 1.5 into 3, 4.5 ohm. In the reading 1, we calculated the voltage by using a multimeter, and we calculated the impulse from the laptop, and which is the software we are using to convert the light wave to sound wave, and we are calculating the impulse. Here the data we got is voltage equals to 0.75 volt and impulse we got is 1. So our working formula is the angular speed equals to number of pulses by time interval into pi by number of slits. So here if we calculate the angular speed for reading 1 is equal to number of pulses, which means the impulse. So we got 1 divided by time interval. In the experiment, we turn on the machine for 3 seconds. So here for the every reading, we will take time interval 3 seconds. So 1 by 3 into pi by number of slits. Number of slits we inscribed on the CD is 1. So the value comes as 1 divided by 3 into 3.142. 1.047. 1.047. For now, the reading 2, the angular speed, we can calculate by the same process. Number of pulses by time interval. The impulse is 0.5 by time interval, which is 3 seconds, into pi by number of slits, which is 1. We will calculate the value. 0.5 divided by 3 into 3.142. 0.523. Now for the reading 3, we can calculate the angular velocity. The impulse is 0.15 by the time interval is 3 into pi by number of slits is 1. We can calculate this. 0.15 divided by 3 into 3.142. We got 0.157. So here you can see that we calculated all the angular velocity for each reading, and for each reading our velocity is different and resistance is also different. Resistance is increasing and voltage is also increasing, but the angular velocity is decreasing. We will now plot the graph between the angular velocity and the input voltage. Now in the graph paper we have to plot the graph between angular velocity and the input voltage. In the x-axis we will put the input voltage, and in the y-axis we will put the angular velocity.